The next thing that we will do is perform a failover test. So let's bring up our user desktop, and there we have a continuous ping to an IP out on the internet going through the primary firewall. When we create a failure, the traffic should be rerouted through the passive firewall, which will become active in our environment. But how will traffic be rerouted to the secondary firewall if you're using the same LAN IP address that we saw on the interfaces? Well, let's go ahead and move this aside. Let's bring up our core switch that has our two firewalls connected based on our updated diagram. So we know that the LAN IP of the PAN appliance is 172.17.99.1. This is the same address that we saw configured on the LAN interface on the passive, the standby firewall. So let's go ahead and view the ARP table for that address to see what the MAC address is. And we'll look at 99.1. Okay, so there we see the IP address and we see the MAC address, and it ends in 0111. Now this is considered as a shared MAC address that both of the PAN appliances will use. We can confirm that MAC address easily by going to the command line interface of the active firewall. Okay, now very quickly, for the prompt name that you see here, you will see the host name of our primary firewall followed by its HH state, which is active, which is correct. Okay, now let's go ahead and view the LAN facing interface on this firewall. Okay, so this will display many things, but one of them is the port's MAC address, and that will reflect the same MAC address that we saw in the ARP table. So that information will be important when we start locating which port is active on the core switch for traffic being forwarded between the network and out through the active firewall, and nothing going through the passive firewall, because that is simply waiting to take over when there is an issue that occurs. Before we do any testing, let's make one more HA change that we forgot to do for when a failover should be triggered besides the entire firewall not responding. So let's go back to the HA configuration page on our primary firewall. And let's go to link and path monitoring section. What we want to do is if the WAN or the LAN facing interface on the firewall goes down, we want to trigger a failure condition, which would do a failover. To do that, we need to add a new link group, and we do that by clicking on add here. Let's give this group a name, something like, we'll say PA links, something simple. Make sure that it is enabled, which it is by default. For the failure condition, make sure it is selected for any, not all, and I'll explain why shortly. And next, we will add both LAN and WAN facing interfaces to this group. So let's add the WAN interface and our LAN interface, and then OK. So the reason that we selected the any option is pretty simple. So if the LAN or the WAN interface goes down, we want a failover to take over. If you would have selected all, then a failover event would only happen if the LAN plus the WAN interfaces are both down. So that may not happen. So we want to be more flexible that if one interface is down, then that is bad, and we want a failover to quickly happen. So once we're done with all of that, let's go ahead and let's commit our changes. And when we do that, we get a message that there is a mismatch between the two firewalls for threat control, which is correct because once again, the secondary firewall does not have an active license for threat content. And that config doesn't involve that. Our config was simply just an HA change for selecting when a failover event will happen. creating a failure condition is what we will call it. So let's go ahead and say OK to make the change, and this change will also be synchronized to our passive firewall automatically. With that completed, let's do our failover test. Let's go back to our core switch very quickly, and let's get the MAC address of the LAN IP of the PAN. Yep, there it is. So that is the MAC address. So now we can confirm which switch port on this switch is mapped to this active IP that we see for 99.1. It should be the primary firewall, but that's what we want to confirm here before we do any testing. So that command we will do is look at the MAC address table, and we'll go ahead and input this MAC address of the active IP for the LAN interface. And doing that, this will show port 12, which is what our active firewall is currently connected to. This is where traffic is being routed through to access the internet. So that is absolutely correct. Now let's emulate a failure by shutting down the LAN port from our core switch. Go to port 12 and we'll do a shutdown. Okay, and doing that, we see that interface is going down. Let's go back to the user computer, and there we see that our ping has stopped running out to the internet. And soon we will get ping responses again after the failover has occurred. Great. Everything's great. So now let's go back to our core switch and see what has happened behind the scenes. That's really important. So let's confirm if the switch port for that LAN IP changes. It should not be port 12 anymore. So first things first, let's view the ARP table again. Let's actually exit out here. Let's go back and view the ARP table. Okay, and there we see the same MAC address as expected, since it is a shared MAC address that should not be changed. And let's view the MAC address table for that entry. Great. And this now shows a different switch port. This shows port number 14, which is what our secondary firewall is connected to. So this change happened on our switches, or on this core switch, because of something called gratuitous ARP. So when the failure happened, the secondary firewall sent out a gratuitous ARP to the core switch, which would then flood that out to other switches if that existed, like the core switch or the access switch that you see in the diagram. So it will be flooded to these switches to instruct them to update their MAC address table with the correct interface for the shared MAC address. And that is exactly what happened here. Our core switch updated its MAC address table for that shared address to port 14. So if we go back to the primary firewall again, let's go to that tab within our telnet window here. Do it a few times. You will see that the prompt here has changed for the HA state. It now shows passive since its LAN interface being down triggered our failover condition. That means our secondary firewall is now the active firewall in our environment, which is also reflected with the switch port that we saw. And because we were paranoid, let's confirm if our user can still browse internet pages besides doing a ping, which is more important to confirm really. Let's go to cisco.com. Okay, and that works as expected. It's always important to test out failover and confirm that your security policies, your NAT policies, among other services, are working as expected after a failover event. And let's view the HA statistics on the dashboard. And here on our first firewall, let's refresh the widget. And there you see that on our primary firewall, it is now reflected as passive instead of active, which is a good thing to check, which means that the other firewall should be in active mode. And we do see it is active in our environment. And when we enable our LAN interface again, and if we wait momentarily, you will see that our primary firewall will become active again because of the preempt and the device priority that we established. So let's confirm that our user still has access to the internet. Let's go to our ping here, and you can see that we are reconnected automatically. On the dashboard of the second firewall, let's refresh the stats that are here within the widget. And you see that the roles are now switched, where this is the passive firewall again, and our primary firewall, let's refresh this, will be in an active role once more. Lastly, let's view the MAC address table again on our core switch, just to make sure which switch port is the active port. And you see that our MAC table has been updated again, reflecting port 12, which is connected to our primary firewall in our environment. Now, before we conclude, I want to give you a very quick slide on how you would configure the data link port if you're using a higher model and you want to use session synchronization. So we couldn't do it in our case because we were using a model that supported only HA Lite. So we can only configure the control link. But if you're configuring the data link, there's nothing different about it. And this is what that option would look like. So of course you would have your dedicated port, whether it is an HA2 port, if you're using a higher model with a dedicated HA port, or you specify which port, an Ethernet port will be your data link port. So you would make that determination. And you of course connect the cable, and you will of course have another IP subnet, very similar for how we configure the control link. And basically from there, you want to make sure that you enable session synchronization. You want the ARP table, the TCP sessions to be synchronized between the firewalls. So it's very simple. Then you specify which port you want to be the HA data link port. Then from there, you specify the IP and the mask, very similar to what we did for the control port. And you can select Ethernet for the transport, which will likely be the case if you're using an Ethernet port. You can also set up the HA2 Keep Alive, which will do monitoring on the data link connection between the two firewalls so that if the data link interface is down, it can do a log to it, a log event, which means you can also set up a backup data link connection, just like how you can set up a backup control link connection. So you can definitely do that if you have enough ports available. So those are things to keep in mind when you want to configure the data link connection between your two firewalls. And that will conclude this video for learning how to configure high availability using active passive mode, how traffic is routed if there's a failure, and how to monitor the HA behavior between the two appliances, including looking at what the switches are doing and learning about gratuitous ARP and how that operates, and looking at the ARP table and using the MAC address, the shared MAC address of looking at the MAC address table to see the exact port that is forwarding traffic for that LAN IP on your network.